Okay, welcome back to my channel, and in this video I will be making a tutorial which will be the second example about the rate of consolidation. So that will be our question 2, guys. Um, okay, so we got a soil condition which is a site of 5 meter deep clay layer underlain by impermeable rock. So this is a clay layer and it's underlain by impermeable rocks, which instinctively you should by now say that this is a one-way drainage. That means water will only flow one way up, which means my drainage path is equal to the clay height or thickness, which is h. Okay. A piezometer is installed in the layer such that it reaches the pore pressure at a depth of 2 meter below the top, such as this one. This is a piezometer that's installed 2 meter below the depth of the clay layer that can read the pore water pressure, U. So I have three readings. We have initial reading prior to fill being placed. So what's going on? That there is a 2 meter deep layer of fill. Just let me indicate that. Um, let's say this is the fill. Okay, that's about 2 meters. It's going to be placed on top of this clay layer. So this fill kind of acts as a surcharge and increase in excess pore pressure inside your clay layer. So before placing this fill, we've registered a reading of 12 kPa. So before applying a surcharge, basically the reading that we have is U. So U without any surcharge is equal to USS plus UXS, right? With no surcharge, the UXS turns to 0 and U is only USS. So therefore, I could conclude that my steady state pore water pressure is 12 kPa. Then our second reading is immediately after fill is placed to be 52 kPa. So immediately after fill is placed, that would be T equal to 0. At that certain point in time, my excess pore water pressure, T equal to 0, will be equal to my surcharge. Okay? So basically my pore water pressure that I just read, which is 52 kPa, equal to USS plus UXS, and USS being 12, which we just found, and UXS is nothing but surcharge, equal to 52, I could conclude that the surcharge equal to 52 minus 12, which is 40 kPa. That means the weight of this fill applied on the clay is nothing but 40 kPa. Last reading is at 50 days, and we registered a pore water pressure of 30 kPa. So we registered at T equal to 50 days that my pore water pressure is 30 kPa. 30 kPa. Okay. Again, we could break this up. We could say U equal to USS plus UXS at that time, and USS is 12. Therefore, my UXS is 30 minus 12, and that's gonna be 18 kPa. So, part A is what is the total unit weight of the compacted fill? So the stress coming from the fill, is the unit weight of the fill times the height of the fill, which is 2 meters. That is equal to the surcharge being applied to the soil. Luckily, we measured that and we actually calculated to be equal to 40 kPa. Therefore, the unit weight of the fill would be 40 divided by 2, so it's 20 kPa. That's the total unit weight of fill. Part B. What is the coefficient of consolidation of the clay? So, part B, What is CV? Well, the only formula where CV fits is TV equal to CV times T over dP. So let's work it out with this formula. Um, we got T. So if you remember, we have the third reading right here. At time equal to 50 days, and we have the excess power water pressure at that point. So can I work out TV from this data? Yes, I can. I can because from this I could work out the rate of consolidation U, and from the rate of consolidation and Z over dP, I can go up to my isochrone graph right here, and found and find TZ. Okay, so let's do that step by step. So I got at time equal to 50 days. We have found that UXS at that time equal to 18 kPa. Now, but we know that the rate of consolidation is nothing but 1 minus UXS at time t over UXS at time 0, which is the surcharge. So it's going to be 1 minus 18 over the surcharge, 40. That will give us a value of, let me see, 18, 0.55. Okay? Now I could say that Z over dP, what's Z? It's 2 meters, which is where I'm reading the data. dP is 5, so 2 over 5, that's 0.4. And my my U percentage is 0.55. Therefore, using isochrones, not isochrene, isochrones, the isochrone graph, I could obtain TV. And let's just do that. We get a clear color. Okay. So my Z over dP happened to be 0.4, so it's somewhere about right here. And my U is 0.55, so it's exactly here. If I go up straight enough, um, up, these two will meet at about this point. If it was actually straight, they will meet about this point. So this TV, this TV, I can see it's not 0.2, it's a bit higher than 0.2, right? Because 0.2 is right here and 0.3 is right here, so it's a bit higher. So let's call it 0.21, just for the sake of saying it's a little bit higher than 0.2. So TV, go back to my green. TV is 0.21. So now we're back here. We've got TV, we've got time, we've got dP. We can work out CV. So CV is TV times dP over time. So TV is 0.21 multiplied by dP, which is the total height of the clay layer because it's one-way drainage. And T, again, T should be in seconds because CV is in meters squared per second. Meters squared per second. So T is 50 days times 24 hours a day, 60 minutes an hour, 60 seconds a minute. Therefore, my CV is uh, about 1.157 times 10 to the power minus 6 meters squared per second. So I just noticed a mistake that this should be dp squared. Just get it fixed. Should be dp squared, that's dp squared, and that's 5 squared. So the value is actually exactly is a bit different than that. it's 1.215 times 10 to the power minus 6 meters squared per second. So that's part B. Let's see what part C is. Part C, what would be the pore pressure in the clay at a depth of 4 meters below the top of the clay layer? And that's 100 days after the filling. So we change the depth and we change the time. So if you remember, the reading happened at 2 meters. Now we are at 4 meters. So what does that mean? Part C. So now my USS at 2 meters is constant to be 12 kPa. However, at 4 meters, it's not going to be the same because we're adding more water, right? So USS at 4 meters is going to be the 12 plus the extra 2 meters of water, which is 31.6. That's for the spatial part. What about the time part? Time is equal to 100 kPa. Therefore, I can find TV to be CV 1.215 times 10 to the power minus 6 times time, which is 100 days, 24 times 60 times 60 over 5 squared, and that is equal to 0.419. Okay, and again, Z over dP. Now Z is 4 over 5. That is equal to 0.8, and my TV equals 0.419. So I can use the isochrones to find my U, the rate of consolidation. So let's check that out. So that over the P was 0.8, which is somewhere here. And then my TZ was 0.41, so somewhere here, right? So these two, they meet at this point. Okay, which would give us about 0.55 or 0.56, okay, for U. So U is now 0.56. Therefore, I could say that UXS at time equal to 100 days equal to 1 minus U times the surcharge. So that's 1 minus 0.56 times the surcharge, which is, we said 40 kPa. That would be equal to 17.6. Finally, my total water pressure. My total per water pressure is gonna be my USS plus UXS. And we said that USS is 31.6 right here. So that's equal to 31.6 plus 17.6. 49.2 kPa. That's at 4 meters and a time of 100 days. Now for question D, how long would it take for the pore pressure at the mid-depth of the clay layer to reach 25 kPa? So at mid-depth, D. At mid-depth, obviously, Z is 2.5 meters, which is 5 over 2. And my total water pressure should reach 25 kPa. And again, this breaks up to USS plus UXS. USS, we are only given at 2 meters, which is 12 kPa. So at 2.5 meters, my USS becomes 12 plus that extra half a meter. 16.9 kPa. Therefore, my UXS is equal to 25 minus 16.9. 8.1 kPa. From the same formula as this, same formula, I would say UXS at time unknown equal 8.1 equal 1 minus the rate of consolidation times the surcharge. Therefore, my rate of consolidation is 1 minus 8.1 over 40 is 0.797, roughly 0.8. And my Z over dP is 2.5 over 5, that's half. So now we could use this, and you could use U equal to 0.8. Back to the isochrone. Therefore, let's read it. Sorry, the screen is a bit shaky. Okay, so from half and U is 0.8, so let's let them meet together. Go straight up to half. Half is right here. So they meet at TZ equals 0.6 exactly. Okay, so my TV equal to 0.6. Now my TV equal to T times CV over dP squared. Therefore, T equal TV times dP squared over CV. That is 0.6. Drainage path is 5 squared over CV, which is 1.21 times 10 to the power minus 6. So that answer will be in seconds, so we must convert this into days. So again, we will divide by 24 by 60 by 60 to get it into days. Therefore, time will be 100 and 143 days. And this concludes this example. Thank you so much for watching.